Monitoring water quality parameters in Trivandrum coast, Kerala using Sentinel images. Abstract: remote sensing has been played an important role in water quality monitoring. The physiochemical parameters of water like suspended sediments and turbidity are an important determinants of water quality in coastal zones. Total suspended solids will increase the turbidity of water, which can affect the water quality. Turbidity is that just a cloudiness of fluid. Various parameters causing turbidity are phytoplankton, sediments from erosion, resuspended sediments, waste discharge, algae growth, urban runoff etc. Then the naturally occurring events like storms, river flows, waves, tides and activities like fishing, shipping and dredging operation also cause turbidity. This study aims to develop and implement regression models for estimating and mapping TSS and turbidity concentrations from Sentinel 2A and 2B satellite images over the Trivandrum coast. Kerala.Concurrent complementary in-situ data for turbidity were collected based on different latitude and longitude. By the collected turbidity values, TSS values can be determined. Using the secondary satellite data, giving latitude and longitude of field data and extracted reflectance values of each band and then regressed with their respective field data of TSS and Turbidity. An algorithm was proposed to obtain the regression coefficient. This algorithm can be used to estimate the TSS and turbidity concentration with a high correlation coefficient, R superscript 2 equals 0.86, for turbidity and R superscript 2 equals 0.82, for TSS. Finally, the map of turbidity and TSS concentration was generated by using the proposed algorithm. This study found that TSS and turbidity mapping can be conducted by using Sentinel 2A and 2B images over the coast of Trivandrum Kerala. The predicted result from Sentinel 2A and 2B imagery exhibit that the predicted TSS and turbidity has a close agreement with the field data with the high R superscript 2 values. Then, TSS and turbidity mapping has been done for validating the results with the in-situ data of turbidity, October 21, 2018 and November 10 and 15, 2018, and got 94% accuracy with mean difference error value of 0.12903. Keywords: TSS, turbidity, Sentinel 2A, 2B imagery, flood, Trivandrum coast, regression analysis and validation. 1. Introduction. Water is an important major source for all living organisms in this world. When water quality is get poor, it affects not only the aquatic life but also surrounding ecosystem as well. A major key factor affecting water quality in coastal waters is the suspended sediments concentrations, which causes non-point source pollution in the area. Guan et al. 2011. Turbidity is an optical property of water and describes the transparency of the water. It occurs in lakes, rivers, and oceans. Turbidity is not itself a pollutant, but it indicates how much sediment and organic matter present in the water. High turbid ocean waters have a large numbers of particulates like sediments and phytoplankton, which reduce the visibility of the water. In addition, turbidity caused by humans also. These anthropogenic causes may originate from wastewater discharges to beam trawling, propeller wash resulting from shipping, as well as resuspension caused by dredging. Total suspended matter such as clay, silt, and organic matter, as well as plankton and other microscopic organisms, interfere with the passage of light through the water and thus cause turbidity. Although total suspended solids, TSS, and turbidity are not same. TSS is a measurement of the non-dissolved solids which are suspended in water. TSS is measured in mg/L. Turbidity is an optical property which scatters and absorbs the light rather than transmit it in a straight line. Turbidity is affected by TSS, but it also determined by the shape of particles, size distribution, refractive index, color, and absorption spectra. TSS absorb more heat from solar radiation than water molecules. So, it increases water temperature and decreases dissolved oxygen. Various models have been used to correlate water quality in remote sensing measurements. Remote sensing studies on coastal waters have generally used regression analysis of satellite data and simultaneous measurements of field data. In the present study, the regression model was developed based on the reflectance value of all bands and the field TSS and turbidity data. Then the algorithm was proposed for both TSS and turbidity mapping. 2. Study area. The study area is the southwest coast of Kerala, Thiruvananthapuram figure 3.1. The geographical coordinates of Trivandrum, i.e. latitude and longitude, is 8.524139 degree N and 76.977081 degree E respectively. Kerala's coast runs some 580 kilometers in length and it varies between 120 kilometers in width. The study area covers the Kovalam, Vishinjam, Pachalur, Shankumugam, Mullur, Puvar, and Edapattu. The coastal zone of Kerala is well known for its rich fisheries, placer mineral deposits, water resources, transport facilities and excellent backwater systems. Kovalam is a small coastal tourist village. It having the small sandy beach protected by rocky regions. Vishinjam is known for its large harbour with rocky coast. Chowra Beach is with sandy coast and Ashimala Beach having rocky coast. Puvar Beach with nice golden sand, very long and clean, only beach in Kerala with sea on one side and river in other side. Due to the industrialization or the urbanization, terrestrial runoffs, and tourist activities etc., where the large amount of sediment is introduced in Trivandrum coast and the adjacent areas. Fig. 1. Base map of study area. 3. Review of related works. M. Mousavi Alishlu et al., 2012, estimated the total suspended sediments mapping by using ALOS imagery on February 16, 2010 over the coastal waters of Langkawi Island, Malaysia. The study aims to develop and implement regression models for estimating and mapping TSS concentrations. An algorithm was developed based on the water reflectance model. The in-situ sample of suspended sediment concentration was collected over the study area based on using handheld GPS, Global Positioning System, on 16 February 2010. Statistical techniques were used. The extracted reflectance bands of satellite imagery were regressed with the in-situ TSS data by using SPSS 19. The study successfully applied a cost-effective method to obtain remote sensing data from the ALOS for remote sensing analysis, and then the proposed algorithm proved to be a useful tool for water quality mapping in coastal water areas. Sami Syuraza et al., 2011, estimated the monitoring of surface water quality in coastal area of Penang. They have used the Landsat TM data. Reflectance model was used. The digital numbers for each band corresponding to the sea truth locations were extracted and converted into radiance and reflectance values. The algorithm was developed from optical model of water. The TSS algorithm produces high R and low RMS values. The water quality maps were prepared by using the TSS algorithm. The water quality image was geometrically corrected using the cubic convolution method and Smoothen to remove random noise. Midyan D. I. Aldabash et al., 2016, have analyzed the multi-temporal satellite imagery for total suspended sediments in a wave-active coastal area Gaza Strip coastal water, Palestine. In the study 2 Landsat TM5 images of 1999 and 2010 were used, and then Landsat TM7 images of 2003 and 2014 and 2015 images of Landsat 2 only were used for TSS mapping. Then 64 TSS in-situ tested samples were used to calculate a correlation equation between DN in each image pixels and TSS values in the ground data. They used linear regression mathematical equation for highest correlation value. By this TSS maps were generated by ILWIS 3.3, Integrated Land and Water Information System, software. Robaba Asadpour et al., 2012, have analyzed a statistical model for mapping of spatial distribution of TSS, total suspended solids, from Thea satellite imagery over Penang Island, Malaysia. Water samples were collected on November 12, 2009 from 13 sampling stations and location noted by using handheld GPS. Then satellite image was geometrically corrected. Reflectance values extracted corresponding to the in-situ location and TSS algorithm was developed based on high correlation. In the study, Regression equation was calculated by using SPSS 18.0 statistical analysis, and TSS maps were generated by PCI Geomatica 10.3 software. Hariyantu et al., 2017, have evaluated the total suspended sediments distribution using ASTER ALOS and SPOT 4 satellite imagery in 2005-2013. Satellite data used in the study was 2005 to 2008 for ASTER, 2010 for ALOS, and 2009 to 2011 for SPOT 4. TSS algorithm were proposed separately for ASTER ALOS and SPOT. Linear correlation analysis were calculated for TSS of satellite imagery and TSS of field data for 2009-2013. They concluded that high TSS value because of Lapindu mudflow to Porong River. It can fatal to ecosystems in research. Aparwida Yantai et al., 2016, have estimated the application of Landsat 8 OLI for total suspended solid, TSS, mapping in Gajamunkar Reservoir 1 Ojiri Regency 2016. In the study, empirical modeling, it integrates the image pixel values and field data using correlation and regression analysis. The field value of April 12, 2016 was used, and then May 8, 2016 satellite images was used. The estimated band 4 have better accuracy in the estimation of TSS. James Packman et al., 1999, have analyzed the turbidity to determine total suspended solids in urbanizing streams in the Puget Lowlands. Data collected from 9 streams. In this, a log linear model used between TSS and turbidity with the regression equation. Nguyen-Hao Kwong et al., 2017, have analyzed the spatiotemporal variation of turbidity based on Landsat 8 OLI in Cam Ranh Bay and Tuy Trieu Lagoon, Vietnam. In this study, an algorithm for turbidity retrieval was developed based on the correlation between in-situ measurements and a Landsat band reflectance. Biljhan Nas et al., 2010, have analyzed the application of Landsat-5 TM image data for water quality mapping in Lake Basir, Turkey. In the study, the in-situ samples of TSS, turbidity and chlorophyll from 40 sampling standards were collected on August 2006. They have used spectral band data and sampling data for bivariate and multiple regression techniques for mapping. Sajid Ahmed Hamidi et al., 2017, have used MODI's remote sensing data for mapping the spatiotemporal variability of water quality in Michigan Lake. In this study, the empirical relationship from 2011 to 13 have done between in-situ measurements of water quality parameters, turbidity and TSS, with the MODI's reflectance values. Then the proposed equations was tested for summer 2014 data. Vismayranjan Tripathi et al., 2018, have used the Landsat OLI sensor for mapping and monitoring the seasonal variability and movement of suspended sediment concentrations along the Thiruvananthapuram coast, southern India. In this study, they have determined the pre-monsoon, March 2017, and post-monsoon, September 2017, suspended sediments. For this they converted the DN values into TOA reflectance, and they also mapped the mean significant wave height along the coast. 4 Materials and methods. 4.1 Satellite data.